Welcome back for lesson 24-2. Now we're going to split this section up into 2 days. So today in day 1, we're going to be solving exponential equations that require the use of logs. Okay, so we have the note sheet that goes with this, 24-2. Something to write with. You might want the root chart, but you're definitely going to need a calculator or Desmos today. Okay. So for many exponential equations, it is not possible to rewrite them in the terms of the same base. So for example, they're using this expression, 3 to the x and 32. Now, if I go back to my root chart really quick that we talked about yesterday, okay, if I look in the base 3, 32 is not an option. 32 will never be a power of 3. So we cannot rewrite this in terms of the same base. So when that's the case, we need to use logs, okay, logarithm statements, and a calculator to solve for x. So none of these are going to work out to be nice numbers. We're going to get kind of weird decimals. But let's go ahead and go through a couple problems together. So in A, we have 6 to the x power is equal to 12. Now, I know you're looking at 12 and thinking, well, I could change that to 6 squared. Remember, 6 squared is 36, not 12. 6 times 2 is 12, but it's not a power of 6. So instead, what we're going to do is rewrite this as a log, so using our same log expressions from before. So this, if I rewrite it as a log, would be log, okay, base 6 of 12 is equal to our power, so it's equal to x. Okay, so logs and exponentials are inverses of each other. We talked about that a little bit in class. So if we're trying to solve for the x in the exponent spot, we can use its inverse, which is a log, to solve for x. So now that x is not in the exponent anymore, we just need to put this part in a calculator and solve for x. Okay. Now remember, the log button on our calculators only knows base 10. So if we have base 10, you can use your calculator. But this problem is log base 6. So no calculator is going to do that. So instead, let's use that log base calculator on Desmos that I made for you guys. Okay. Now I have it into 2 parts now. I added the natural log for you guys if you need that, the ln. But since we have log base 6 of 12, we're going to use that top one. So let me go back to that. So we're going to change our a value to 6, and our base we're going to change to 12. So remember, you can use the slider, so if it's easier, you can also just type in the number that you need. But here it spits out your answer. So 1.3868. It says round to 3 decimal places, so we'll do 1.38. We'll round that up to 7. 1.387. 1.387, and we are done. Okay, so again, we're using the calculator to do most of the work here, but there you go. All right, let's look at B. We have e to the x power is equal to 91. Now, when we rewrite this as a log, remember log base e is that special log that we have. So log base e is our natural log. So this would be the natural log of 91 is equal to our power equal to x. And that's why we spent so much time practicing rewriting these into the other forms, so we can do this problem right now. Okay. Now your calculator does have a natural log button, so if you click ln, forget the number already, ln of 91, okay, it will spit out our answer, so 4.511 if we round that up. But if you don't have a graphing calculator or a scientific calculator for ln, you can use the Desmos. I set it up for ln. So we needed the natural log of 91. So I'm just going to type in 91 here. Make my life a little easier instead of using the slider. But there you go. See how we get the same exact answer that I got in the calculator. So 4.511 is our overall answer. X. I forgot what it was. 4.511. Now, as long as your answer is close, if we round a little different, that's okay, but that's how you do it. All right, let's look at the next couple. Now we have 2 to the x plus 3 power plus 7 is equal to 25. So in this problem, what we have to do is get the exponential by itself first. So I'm going to start by subtracting that 7 over. Okay, so we have 25 minus 7. We get 18. So 2 to the x plus 3 power is equal to 18. And again, 18 is not a power of 2. You can see it's not on our root chart, so that's why we can't do what we did yesterday. We have to use logs. So watch me rewrite this. We're going to take log base 2, number of 18. We always set it equal to our power, so it's equal to x plus 3. So we plug this into the calculator. We're going to go back to Desmos, do log base 2 of 18. So log base 2 of 18. There we go. So there's our answer, 4.1699. So let's round that to 4.170. So this was 4.170. Now that's not equal to x, that's equal to x plus 3. So in order to get x by itself, we just have one quick little extra step. We're just going to subtract the 3. So 4 minus 3 would give me 1. 1.170 is equal to x. Okay. One last one. Let's look at e to the 2x minus 4 power is equal to 148. So again, remember that if it's base e, we're going to use the natural log. The natural log of 148 is equal to our exponent, 2x minus 4. So let's find the natural log of 148. Again, you can use the Desmos. What is this? Natural log, we need 148. So that gives us 4.997. So let's round that. 4.997. We'll just keep it like that. 4.997. So this was 4.997. Now we still have to do a little extra work here. We have a two-step equation still to solve for x. So let's start by doing our 2 steps. Okay, I'm going to add 4 to both sides. That becomes 8.997. Okay. And then final step, divide out that 2. So this I probably will need a calculator for. So 8.997 divided by 2. You get x is 4.4985. So we'd have to round that up. So 4.499. So again, none of these are going to work out to be nice answers, and that's okay. Just round your decimal to 3 places, or whatever the directions say. If we're close, then we're good. Okay. And you can always check your answer by plugging it back in. It might not give you the exact 148 in this particular problem, but it should be close enough. Okay. So let's have you guys try 2 problems here. Number 1, you have 8 to the x is equal to 100. So rewrite this as a log statement to solve for x. Plug it in your calculator or Desmos, okay, and see what you get for x. Round to 3 decimal places. Okay, here's what I got. 2.215. So if you have something close to that, you probably did it right. Here is my work. So I rewrote this as log 8 of 100. So then I just need to go to Desmos. Our base is 8. This was 100. So 2.21, I rounded it up to 5. All right, one last one. We have e to the 2x minus 1.5 is equal to 6.7. So start by moving that 1.5 over. To undo the e, make sure you use the natural log. Okay, and then solve for x. So go ahead and try 2, and then we're done for today. Okay, here's what I got. I got 1.052. Okay, so let me show you my work. I added the 1.5 over and got e to the 2x is equal to 8.2. I undid the e with the natural log. So the natural log of 8.2 is equal to 2x. So putting this in the calculator, natural log of 8.2. Again, you can use Desmos. You would just have to kind of type in 8.2. That's okay. You get this decimal, which is what I got, and then divide both sides by 2, and you should get your final answer. Okay. So again, we have to use logs, the inverse function of an exponential, when we can't change them to the same base. Okay, like 6 and 12, okay, 2 and 18, 8 and 100, they did not have the same base. So instead we use inverse functions or the logarithms to solve for x.